When you think about osmosis, you might just remember a high school biology class, but did you know that this simple process is happening all around us, even inside our bodies? Osmosis is the movement of water across a semi-permeable membrane, and it's vital for keeping our cells alive and functioning. So let's break it down. At its core, osmosis is all about water moving across a semi-permeable membrane. That's a membrane that lets water molecules pass through, but keeps larger molecules or ions, like sodium or chloride, out. Osmosis is a passive process, meaning it doesn't require any energy input. It's simply water moving from where there's more of it to where there's less to help balance things out. Let's imagine we have a lab beaker with two compartments labeled A and B, separated by a semi-permeable membrane. Both compartments start off with equal concentrations of salt sodium chloride. In this state, we say that A and B are isotonic to each other, meaning they have the same concentration of solutes. In this balanced state, water molecules move back and forth across the membrane equally, and there's no net movement of water from one side to the other. But what happens when we add more salt to side A? Now, compartment A has a higher concentration of sodium and chloride ions than compartment B, and we call this hypertonic compared to B, which is now hypotonic. Because water molecules are free to move across the membrane, there will be a net movement of water from side B to side A until the concentrations are balanced again. Now, why does water move from the hypotonic to the hypertonic side? It all comes down to kinetic energy and entropy. Water molecules, sodium ions, and chloride ions are all in constant motion, like toddlers running around a room. When you add more salt to side A, there are more sodium and chloride ions bouncing around, getting in the way of water molecules trying to pass through the membrane. These ions aren't physically blocking the door like bouncers, they're just constantly bouncing into water molecules, which makes it harder for water to leave side A and move to side B. Additionally, sodium ions are positively charged, and they attract the slightly negative oxygen atom in a water molecule, while chloride ions, which are negatively charged, attract the slightly positive hydrogen atoms in a water molecule. This means water molecules are more likely to stick to these ions and stay on the hypertonic side, leading to a net movement of water from the hypotonic side, B, to the hypertonic side, A. Osmosis is not just a lab phenomenon, it's crucial for our cells. Let's say we take a red blood cell and place it in a hypertonic solution like vinegar. The surrounding solution has a higher concentration of solutes than the inside of the cell, so water molecules will move out of the cell. As a result, the cell shrivels up, almost like a raisin. Now, what if we place the red blood cell in a hypotonic solution, like pure water? Water molecules will rush into the cell, causing it to swell up and eventually burst. Not exactly a good outcome. This is why intravenous, IV, fluids used in hospitals are isotonic, containing sodium chloride in concentrations similar to those found inside our cells. This way, the net movement of water in and out of the cell is zero, and the cells remain healthy and happy. So, the fundamental idea behind osmosis is that water molecules move from an area with low solute concentration to an area with high solute concentration until both sides reach equilibrium. This process helps regulate everything from the water balance in our cells to nutrient absorption in our bodies. Alright, let's recap. Osmosis is the movement of water molecules across a semi-permeable membrane from a hypotonic solution to a hypertonic solution. It's a form of passive diffusion, meaning it doesn't require energy. When there's a higher concentration of solutes on one side, water molecules will move toward that side to balance things out. This process is crucial for keeping cells hydrated, maintaining proper function, and ensuring that our bodies stay in harmony. If you enjoyed learning about osmosis and want more deep dives into science concepts, be sure to like, subscribe, and check out King of the Curve for more educational content. Stay curious, and I'll see you in the next video.